Hello, Jim. Alright, yeah. Hello, everyone. Uh, Jim, happy weekend. Uh, Welcome to today's stream. Alright, it's good to be live again. If you're new here or if you're joining this stream for the first time, right? My name is Julius Jules. Right. So, if you're returning, yeah, you're welcome again. Um, like I said earlier, happy weekend. It's always a week. It's always a long week. I but yeah, the weekend is finally here, and even though it's just few days, the cover night weekend is gone again. But still, it just gives us that that time to just refresh and go again for the following week, for the coming week. Right, so it's always amazing to get into weekend. Just the energy needs to be renewed and all. Right, and how did your week go? Right, my week was not so bad. Starting a week with holiday, eh, so it's one of those proper Niger jollof feeling. It just makes you feel relaxed. There's no much pressure going into the week when the week starts with an holiday. So the Easter Monday holiday was, should I say it was a blessing. Alright, so yeah, and the week in general it wasn't so bad. It wasn't so bad, no. Just had to do what we are paid to do, and also keep learning and building and all of that. All right, so it's good to be here again. It's good to go live again this weekend. So yeah, this weekend is going to be a fun one too. All right, so we'll be we'll be learning and building amazing stuff. All right, so from the topic or from the title of this stream, as our focus is on RIP. Right, so our focus is on RIPv2, and that's what we aim to build today. That's what we aim to work on today and learn about. Right, and it's one of the most important thing, or one of the very important things in the CCNA exam line, right, and even also in networking generally. So, and today we'll be learning about this. All right. So yeah, let me just get things up. Oh, oh, shit. So I've said a lot without saying anything. Hey, please, if you can hear me now, just drop a comment. You can hear me now. My mic was muted and I didn't know. So I was saying, this is the resource we'll be using for our live stream, right? So we'll be building labs in this website, and basically the name of this website is itexams.net, and I've added the link. The link is scrolling on the screen now. All right. I discovered this website, and it's a handful of resources. It's a handful of resources, from practical exam questions and answers. That's for CCNA, practical CCNA exam questions and answers, to CCNA labs, and it's just has a lot. That's a lot, and it's going to be it's going to be something fun to work with. And I mentioned when my mic was muted that I think we're going to adopt this particular website for most of our labs now. Right, for this particular stream. So there are 120 CCNA labs, right? And I think it's just going to be a fun challenge to take it upon us and complete the entire 120 labs, right? And these are all of the labs are they are important things that they are the important labs that are worked on for the CCNA exam, right? So it's just a lot. It's just a lot. So it's even 130. All right. So this is lab 130, and it's keep checking, keep checking, keep checking. It does have the entire pool of labs, and also here are the questions and answers. CCNA questions and answers, which you can study for CCNA 1 to CCNA 4. Right. So yeah, it's going to be a fun journey, and I think this will even make our stream easy, because we know what's happening next, or what we're doing next, or it will give us a proper guide to building. So I'm optimistic about this one, and yeah, I feel it's going to be an awesome journey. All right, so yeah, like in the title of our stream today, we're starting with RIP version 2. That's so it's one of those important protocols in networking, and let's see what it entails, let's see what it means, and how it's being used, right? So I'll just bring up my best friend. So my best friend is going to help us with a lot, and give us some foreground into what wants to what wants to learn. So yeah, let's get started. So this is lab 27, right? So there are some labs before this, but I just thought of picking it or starting from here, right? So if you really want to make use of these resources, or you want to go over the previous labs that we might have skipped, maybe from lab 1 to lab 26, right? You can click on the link or you can just copy the link that is scrolling on the lower third of the screen. All right, so now let's see configuring RIP version 2. All right, so this is just table of contents regarding what we'll be touching in this lab. And now the objective of this lab exercise is for you to learn and understand how routing information protocol version 2. Okay, is to understand how to configure routing information protocol version 2 on a Cisco iOS router. And what's the purpose of this lab? So RIP version 2 configuration is a fundamental skill, right? By default, when RIP is enabled in a Cisco router, both version 1 and version 2 updates are sent and received. So since RIP 1 is considered obsolete because of today's subnetted networks, it is imperative that you know how to enable RIP version 2. As a Cisco engineer, as well as a Cisco CCNA exam, as well as in the Cisco CCNA exam, you'll be expected to know how to configure and verify um, RIP version 2. Right. So, like I mentioned earlier, it's an important aspect of network engineering, or even Cisco and Cisco network engineering, and also it's very important. It's a very important aspect of the CCNA exam. Right. So the lab is suitable for both CCNet, CCENT, and CCNA certification exam preparation, and the lab has a difficulty rating of 5/10. So it's pretty medium. So it's not expected to be something that is going to maybe trouble us. But we are engineers, right? We're network engineers, and that's why we are engineers. We are to um to work on and solve technical problems. So whichever the difficulties we are supposed to tackle is, but no, this is just this is welcoming, and this is just something to get us into what RIP version 2 is. So difficulty of 5/10 is not so bad, right? And when you're ready for your certification, when you're ready for your certification exam, you should complete this lab in no more than 10 minutes. So that's for the exam purpose, right? But for the purpose of this stream, we're going to break it down, right? So for everyone to understand, right, you need to understand the concept and why um what RIP version 2 is really about, right? And so this is the topology we'll be using. So it's a pretty basic one. So just two routers, and we're going to connect these two routers and see. All right. So before we get into the task, right, we have our topology. So maybe I should just create that first. All right. So what kind of cable is used there? Okay, serial connection. So we need to add a serial port to this. So I just want us to create the topology first, then we can go into seeing. So I need to add a serial port to this, a serial port module to this router. Yeah, this has a serial port. Oh, sorry, it's the power of the router. So yeah, as you can see, the interface is a Cisco 2-port serial speed 1 interface card, so providing two serial ports. So this is all we need. So I'll just toggle this on, and yeah. Oh no, I need to fix something. I think I'm sharing the screen in a wrong way. All right. Apologies for that. So I had to fix how I was sharing my screen. All right. Okay. So I've added the serial port module to this router here. I so I'll have to do the same for the second router. So I need to turn it off and then I can turn it back on. Alright, so now I need to connect to my serial. So I'm connecting serial 0 to serial. Alright. Alright. So now before we proceed with configuring all of this, now before we start with our configuration and all of the tasks that are listed here, let's take a walk back to understand what um RIP version 2 is, right? But before even that, let's understand what is routing protocol. So we need to understand what routing protocol is before we even know what um before we even know what RIP version 2 is, right? What is routing protocol in networking? Right, so it says routing protocol in networking is a set of rules and algorithms that routers use to communicate with each other and determine the best paths for data to travel across the network. Right, and simply call it packet also. Okay, I think let me adjust this. Right. All right, so this is a simple explanation. So think of a routing protocol like a GPS system for your internet. It helps routers decide where to send data, which path is fastest or most efficient, and how to adapt if a path becomes unavailable. All right, so routing protocols are important, so in large networks like the internet or in enterprise systems, there are many possible paths between devices. So routing protocols automatically update routes, handle network changes, failures or congestion, more like load balancing aspects, and optimize traffic flow. And how does it work? Right, routers use routing protocols to share information about network paths, build routing tables. That's the routing table is the list of best routes which packets can travel through. Select the best routes based on metrics like up count, bandwidth, delay, and cost. Right. And what some common routing protocols we have. There are some widely used ones, right? We have our distance vector protocol. Right. An example is RIP. Right. I think when we're explaining or when we're reading it here, okay, it was not mentioned here, right? But our RIP is the distance vector routing protocol. Right, sharing information with neighbors. Um, distance vector routing protocols. Example is RIP. This one shares info with neighbors. Simple but slower to coverage. Right. So the larger the coverage, the more slower it becomes. Alright, so link state protocols. Alright, an example is the OSPF. Alright, so this one makes use of the full map of the network and selects which route is the best to send packets through. And this one is considered to be more faster and more efficient. Right, then we have the hybrid protocol. Right, this example is the EIGRP, and this one combines features of both link state protocols and distance vector protocols. And lastly, we have the path vector protocols. This example is BGP, and this is used on the internet between organizations like ISPs, right? So routing protocols do not move the data themselves; they just decide the best path. So the actual forwarding is done by router based on the routing tables, right? So now we have a background understanding of routing protocols now, and this is applied to just routers alone. And what routing protocols basically do is they dictate or they suggest the best path for routers to they decide the best path for routers to travel through. They decide the best path for packets to travel through, and yeah, they don't move the data themselves. They just let the packets know, okay, which is the best path to travel through. That's it. So yeah, we'll get into understanding what RIP version 2 is about now. So let's see now what is explain RIP v2 and how it works. All right, so just some few moments. Need to fix up something here. So I just discovered I've been sharing the thumbnail I've been using is the wrong one, so I need to quickly change this. Okay. All right, so let's get back into it, right? So now, what is RIPv2? So RIPv2, which is basically routing information protocol version 2, is a distance vector routing protocol used by routers to automatically share and update routing information within a network. It is an improved version of RIP, which is RIPv1, fixing several of its limitations. All right. So what makes RIPv2 different? So RIPv2 adds important features that make it more practical for real networks, right? One, it supports subnet mask, CIDR, or VLSM. It uses multicast instead of broadcast. It includes authentication for security and best route control and stability, though still limited. So how does it work? Periodic update. So every 30 seconds, each router sends its entire routing table to its neighbor, right? And up count. RIPv2 chooses the best path based on up counts. That's the number of routers the packet passes through. So one up is equals directly connected router, and maximum allowed is equals 15 ups. 16 ups is going to return unreachable or infinite. So it only works well for small networks, right? So route learning process. So router receives routing updates from neighbors. It compares route and selects the one with lowest up count, right? It updates its routing table accordingly. Routing table maintenance. Each route has timers. So update timer, that's 30 seconds. So every 30 seconds it sends updates. Invalid timers, that's approximately 180 seconds. Mark routes as invalid if no updates within a period of 180 seconds. Flush timer. So if as at after trying, repeatedly for 240 seconds and there's no the part is not returning any packet, then it's going to flush out the route completely. Right. So also loop prevention techniques. So RIPv2 includes mechanism that to avoid routing loops, right? So split horizon, don't send the route back to where it came from. Route poisoning, mark bad routes with up counts because 16. Hold down timers, ignores unstable routes temporarily. Right, so and these are example scenarios. Imagine three routers, router A, router B, and router C. So if router A wants to reach router C, B tells A, I can reach C in one loop. A updates its table, C is two loops away via B. Right. So a loop to from A to B, then from B to C. So that's two loops away from A. So that's what it explains. So advantages: simple to configure, low resource usage, and good for small or lab networks. Right, and also what are the disadvantages of RIP? It has a slow coverage, right? Because of its up counts. It has just maximum of 15 up counts. So that means if there are more networks on if there are more networks or a large network, right? If the up count exceeds 15, that means RIP is not going to work in such case because of its limited number of ops. Right, so slow coverage, limited to 15 ops, not scalable for large networks. I just explain this, and it is also less efficient than modern protocols like OSPF or BGP. Now, what are the key takeaways from here? So RIPv2 works by periodically sharing routing tables and choosing the best path with the fewest ops, but its simplicity comes at the cost of scalability and speed. Alright, so I think this gives us a background knowledge of what RIP is and how it works and what it tends to achieve in networks. Alright, so now let's go back to our lab and let's configure this. Oh, sorry, this is the wrong screen. Alright, so now let's start with solving all of this. So configure the host names on router 1 and router 2 as illustrated in the topology. Okay, so this is the host name, L0 100 and L0 101, I believe. Or let me just confirm from there's no particular host name that was configured here. It's still just R1 and R2 I can see from here. R1, R2. Maybe I'll just name it R1, R2. Really nothing. So let's configure the host name. So I'm going to the CLI. Okay, I'll use my R1. So let me go to my router 2. I need to do physical configuration to R2 display name. I need to change this to R1. Alright, so we've done that. Then task to configure a back-to-back serial connection between R1 and R2. So configure the DC interface serial 0/0 to R2 to provide clocking to R1 at a clock speed of 2 Mbps. If this is the DC and wait, let me confirm. So yeah, we need to change our cable. So we have to use a serial DC cable. So I use the DT. So I'm changing this now. Alright, so before we, so as not to cause confusion on, let's see what the difference is between a serial DC. What is the difference? Okay, so it says the difference between CRDC and CRDT cable comes down to who provides clocking in a serial connection. And the basic idea, CRDT basically means data terminal equipment, and it's used for end devices like a router or a computer. While the DC is data circuit terminating equipment, device that provides timing or clock signal. So DT provides sends or receive data, receives clock, no clock config, and then the typical side is a customer device. While DC controls timing, provides clock, whereas clock rates service provider side. Serial connection, data must be synchronized. That's where the DC cable comes in. CN generates a serial clock, and the CN uses the clock to send data at the right time. Okay. All right. So I think we understand from this that the DC provides timing while the DC follows the timing provided by the DC. All right. So what else do we do from here? So it says configure a back-to-back serial connection between R1 and R2. Configure the DC interface serial 0/0 in R2 to provide clocking to R1 Oh, I think I must have made a mistake. Right. Now, the R2 interface is supposed to provide clock into the R1. Okay, so I need to change this connection. Uh, Connect this. All right. So yeah, this is the correct way of connecting it. All right. So now the DC interface is directly connected to the router 2, while the DT is connected to the router 1. So configure IP addresses 192.168.0.1 um, slash 30 and 192.168.0.1 slash 30 on R1 and R2. So yeah, 0 slash 0 interfaces respectively. Configure the loopback interface on R1 with IP addresses illustrated in the topology. All right. Now let's get into this configuration. So it has been provided for us here how we can configure this, and we really need to understand how this configuration works. But yeah, before then, let me just quickly attend to something. I'll be right back. All right. Sorry for the apologies for the breakouts earlier to take a pee. All right. So now, yeah, let's go into configuring all of this. All right. So the first task we have here is to configure a back-to-back serial connection between router one and router two. We need to configure the DC interface serial 0/0 in router 2 to provide clock into R1 at a clock speed of 2 Mbps. So now, yeah, so we have the guide as to solving this. So now let's come to our router 2. So soon inside our router, let's go to interface SE0/0/0. All right. So from here it says clock rate 2 MB. Then we end. Now proceed to configure IP addresses. All right, so let's just do that. So we need to do clock rate. Oh, sorry. Clock rate. So we're doing 2 Mbps. So that should be 200,000 or 2 million. This is in beats. So, alright. Then after that, I can just do end and show controller serial port 0/0/0. Okay, as you can see, these are hardware, and these are DC interface, and these are clock rates for this DC interface, right? So it seems we are just good with that. So I think we're just good with that. So now it's more. You just see a lot of things. Ooh. Okay. So now next thing we want to do is to configure IP addresses for user interface. So in my router 2, let me just continue from here since I'm in my router 2. So interface SE0/0/0, and I want to do IP address. So what's the IP address we have to use here for router 2? So that's going to be 192.168 .0, I think, .0/ okay, .0.2 and 255. So we're dealing with /30 252. All right. No short to write memory. Then let me come to this router 1 and configure same. So yeah, and conft then IP address. All right. So we have configured IP addresses for these two interfaces. Then we need to configure look back on our router one with IP addresses illustrated in the topology. Now, how do we configure our loop back? So interface loop 101. Okay, so interface loop 100. Then we add this. Then before we configure this loop back, right? So I know we've talked about IP addresses and maybe we are familiar with that and subnet also. Or what is this loop back? So let's ask our AI to explain what this loop back is. Right. So what does loop back mean? Okay. So in networking, a loopback refers to the way a device sends traffic to itself for testing and troubleshooting purposes. Alright, so what this simply means is a loopback is like talking to yourself to check if your voice works. Testing while to so I think it's just something of that manner. Right. And instead of sending data out to another device, the system sends data, immediately receives back internally. So this is just a router communicating with itself in order to test if the connection is active and if it's working properly. So the loopback address, the most common example is the IP address. Now 127.0.0.1, it's called a local host, right? I think we get to use this, or we get to see this on our computers, especially when we are testing something locally. If you're a developer or maybe you're trying to run something from your own system, right? And within your system, you get to see um, this IP address 127.0.0. So that's just the local host address. So while loopback is used, it's used to test network stack. So you can check the TCP IP. You can check if TCP IP is working correctly without needing any external network. So we just ping this, right? It's used for troubleshooting. If loopback works, issues internal. If loopback fails, issues local. Sorry, external and local. The router configuration, right? Routers like Cisco devices use loopback interfaces as virtual interfaces. They are not physical, always up unless manually shut down, and it's used for router IDs in OSPF, stable management IPs, testing connectivity, and so on. So types of loopback, we have the software loopback, which is internal, like the 127.0.0.1, and we have it is not a physical, there's no physical hardware involved in this. And we have hardware loopback that's used in testing cables or interfaces. So signal is physically looped back, right? And what are the key takeaways from understanding loopback? So a loopback is a method for a device to communicate with itself, and it is mainly used for testing, troubleshooting, and stable network identification. Right. So now let's get back. Since we understand what loopback is now, so let's go back to configure our loopback for this router one interface. Right. So and this is how the configuration works, right? So we need to go into the interface. So I can just see it. Interface loop 100, I think. Here. Then now once configure IP address for this. So IP address 10.10 10.10.100.1 255.255.255.254, I think. Okay, dot 224. Okay, so this is /27/26. So 224 Then I can now go to interface loop. Is it 101? Okay, 101. 101 and IP address 10.10.100.2, I think. Okay, so this is 101.1. Sorry. Then it's going to 255.255.255 dots is 192. Okay, so I missed. There's a typo here. Address. All right. So the next thing. Okay, I think we've configured our router too. Yeah, we configured it after configuring the clock rate. All right. Configured our router after configuring the clock rate. So what's next? Now configure loopback on. Yeah, we've done that. So now I think what's next is the task 3, but let me confirm from this here. So the task 3 says enable RIPv2 on router 1 and configure RIPv2 routing for the loopback interfaces and the serial 0/0 interface. To verify on either R1 or R2 that RIPv2 has been enabled using the appropriate command. Alright, so now in task 3 here, we want to configure our router RIP. Right, so we've been basically working with interfaces in the previous task. Right, so now it's time to configure the RIP itself. Right, so to do this, I need to go to my, okay, I'm still in my router 1. Then so conft. Alright, then I want to do router RIP version 2. Right, so what's next? So we have to add our network address 10.0.0 and also 192.168.0.0.0. Okay, so we're using 10.0.0 because that's for the loopback interface, and we're using the 192.168.0.0 because that's the configuration for the serial 0/0 interface. So now let's configure this. So I want to add network 10.0.0.0. all right, so this network address, network 192.168.0.0. all right, then can end this. So let me just write the configuration. Alright, so that's that for R1. Then I can come back to R2. Now for R2, what are we to configure? Alright, so because we didn't use loopback interface on our router 2, so we should only be configuring for our serial interface. So switch. Alright, so I can now come and say conft and then I also do network 192.168.0.0. then right, so now we have configured our router 2, right? So then when configuring RIP routing, you must use the version 2 keyword under RIP configuration mode. So by default, if RIP is enabled and this keyword is not used, the Cisco iOS router will enable both RIPv1 and v2. RIPv1 will be enabled for inbound and outbound routing updates, and RIPv2 will be enabled only for inbound routing updates. Right, this is illustrated below for a routing configured for RIP routing without using the version 2. So when you skip the version 2 command while setting up your RIP, or while configuring your RIP, if you choose to ignore or if you skip it and by mistake, right, your router is going to be configured solely for RIP1 being enabled for inbound and outbound routing updates, while RIP2 will be used only for inbound routing updates, right? So, and this is what a practical example looks like. So, show RIP protocols. Routing protocol is RIP, so sending updates every 30 seconds. Next in 9 seconds, valid after one, blah blah blah. So here we can see our routing protocol here is RIP, which is basically RIP1. So instead of the RIP2, which we ought to be using, right? So the next thing to remember is when enabling RIP is to always specify the network at its major classful boundary. So regardless of the fact that it has been subnetted, for example, router 1 has loopback interfaces, two loopback interfaces, 10.10.100.1 /27 and 10.10.101.1 /26, which is the subnet. So because these are part of the 10.0.0.0/8 subnet, which is a class A address, right, the RIP network segment statement is configured using their major classful boundary, and is configured as a network 10.0.0 in RIP configuration. Right. I think one of the most important things maybe I might not have covered or talked about at all in this stream, right, from the first episode is the understanding of IP addresses, and maybe I'll just find a stream where we really explain IP addresses and how it works and how it's calculated and how we can even do subnetting. So, well, I might as well go ahead to maybe recommend resources you can use to understand IP addressing and the entire subnetting thing. Right. So now let's just test our. Let me come here and say show IP. Okay, so routing protocol is RIP, sending updates every 30 seconds. Next 27 seconds, right after 180 seconds, blah blah. So outgoing updates filter list for all interfaces is not set. Incoming updates filter list for all interfaces is not set. So it's distributing RIP and default version control to send version 2, receive version 2. Right. Okay, I think this is where it's particularly specify. So this, if you configure without using the version 2 command, you are going to see just send version 1 and receive any version, right? But when we make use of our version 2, right, so we are going to get this. We're going to our router is going to return this, right? So send default version control, send version 2 and receive version 2. Then all of the interfaces that were configured right? So we have interface serial ports 0/0, loopback, and 101. Right, so everything is version 2.2. That's send and receive version 2, version 2, version 2. So same thing here. Right. And automatic network summarization is in effect. So maximum path for routing for networks. Right. So let's see how. Let me just ask how do we test say site show. So let's see how we can test our RIPv2. Okay, so it says we can use the show IP route. Show IP route. So this is going to give us a breakdown of different interfaces and how they are connected. Right, and you can see here. So this is variably subnetted, so 4 subnet and 3 mask, and they are directly connected to loopback. So this is directly connected to loopback, and this is directly connected to loopback too. Then we have this IP address. It's variably subnetted, 2 subnet and 2 mask. So one is directly connected to serial ports as 0/0/0. And this is also directly connected to serial port 0/0/0. So this is a local connection. Right, this is a local connection. This is a local connection. This is a local connection. Right. So which other test is AI giving us? I think I need to check for something. Actually, something is case of last resort is not set. Come, let me do this from here. Okay, so this is it. So this is our RIP. So we can also, so let's ping. So now let's try to ping 10.0/0. No, it should be pinging. Let me see. Let's pick an interface from here. So 10.10. Are we going to be able to ping a loopback? Let's try. I've not tried it before. All right, so 10.10 does 100.1, I think. Okay. Okay, yeah. So um, it's able to connect, or it's able to communicate with the loopback on router 1. So I think this wouldn't have been possible if there was no um, routing interface. There was no successful um, RIP protocol. Okay, so let's try the traceroute command also. Traceroute. Let me just use traceroute. So 192.168. Okay, yeah. So this is the route through which this loopback is communicating, or this router is communicating with the loopback. So 192.168.0/1. Right. Let's under this. Okay. All right. So let's test with this. Let's test with this command also. So let's debug RIP. Debug RIP. IP RIP. IP protocol debug is on. Okay, so receive via version 2 updates from 192.168.0.1. So let me just make this stay at the top. So let me bring up this CLI also. Okay. So you can see from our router 1, it sent V2 update via now to 2240.0.9. Oh, let me just stop this. So how do I stop it? On debug or alright, so from our router 1, it's okay. From router 1, sent this update to 224.0.0.9 via serial interface. Right. So the serial interface is 192.168.0.1, which is connected to this. That's the IP address of your router 1 itself. Alright. Yield update entries. Then it's sent to loop back also. Sent to loop back. So basically, from all this, from all of these tests we have run here, right? So I think it's justifiable that um, we've been able to set up, or we've been able to complete this lab. Right, so we've been able to successfully set up our, you know, everything that is required, or all of the tasks required of these configuring RIP version 2 lab. So if you're still tuned in, right? If you have a question, you can send it to the comments. You can drop your questions or your opinions to the comments. Drop your opinion or questions to the comments. Or let's see if we can quickly go. Let's see the next lab. Says automatic summarization. RIPv2 automatic summarization. So let's see what this is about, and let's see how we can configure this. Alright, the objective of this lab is for you to learn and understand automatic network summarization using routing information protocol version 2 on a Cisco iOS router. So by default, when RIP routing is enabled on network, it performs summarization at default network boundaries. So I think the keyword in this particular lab now is network summarization, automatic network summarization. So let's see what automatic network summarization entails. So what's this about? Automatic network summarization. So it's a feature in routing protocols like RIPv2 where routes are automatically summarized at their classful network boundaries. Right, so instead of advertising many specific subnets, the router groups them into one larger summary network. So suppose you have this network 192.168, blah blah blah. Then with auto summary on, the router advertises 192.168.0.0/16. Okay, this makes sense. Okay, so let's see if I think I actually do have a limited time today. Let's see if this is what we can. Uh, I think this particular lab is what we are going to deal with in our next stream, right? So I have a limited time. I have some other things to jump on after this stream, so I won't have the whole time to go into um, you know setting up and solving this lab. But in our next stream, we're going to we're going to have this done, and this is where we'll be starting from. And so we'll be starting with lab 28 in our next stream, and let's just see how it goes, right? But I've provided the link to this particular resource. It's in the okay. I can add it to the comment section also. I think. Right, I can add it to the comment section. so you can access it. Right, so you can access it. And so if you have interest in trying this out, or even solving this lab before the next stream, right, it's going to be fun. It's going to be fun. So you can just do that and challenge yourself. Right, so I think that's just all we have for today. Right, so we've been able to see what routing protocol is, and particularly uh, we analyze, or we learned how we can set up our we learned how we can set up. Sorry, I'm coming. All right, so yeah, we learned how we can set up our RIP version 2. We learned about RIP version 2 and what it entails, and we're able to play around the lab of two routers, right? Two Cisco routers, and we did set up RIP version 2 on these labs. Worked with clock rates, and also worked and learned about loopbacks, right? Loopbacks being local testing networks within just a single router, right? So just a way a router can test itself for communication, before even sending packets outside, right? And we were able to touch all of this, and we're able to solve the lab that was attached to this particular learning, right? So it's been a good one. It's been a good one, and I've learned something new this weekend, and will come next week, right? So we're going to pick it up from still this RIPv2 configuration, and next week we'll be dealing with automatic summarization, right? So we'll see how we can make use of our RIPv2 to learn and understand automatic network summarization, right? So it's promised to be an amazing stream too. Promised to be a fun one, and I hope to see us all in the next stream, right? So I think we've got to that part again. So where we do our review, right? So we want to reveal and do a special shout out to builders and contributors. So we want to do a special shout out to builders and contributors who are contributing to amazing things in the tech space. And who do we have for this week? So who are we giving a shout out to this week? So I finally found how I can make use of sound effects, right? So okay, I think it's the streaming app I'm using, right? The one I used previously didn't have all of those paparazzi and fancy sound, but this one has. All right, so shout out to EVMox. Thank you for giving us a freemium tool like this, where we can even stream at a better quality with good features, right? So now want to reveal our who is going to want to reveal our special shout out for this week, or for this weekend, right? So in my post on LinkedIn, I asked if everyone can just drop a guess of who this special shout out is going to be. Alright. Well, I didn't get any comment as regarding that though, so we are pretty new and still coming up, so maybe we don't have that traction yet, but with time. But let's get into it now. Shout out for or our builders, innovators, creators shout outs for this week goes to, let me use the sound effects. Yeah. So yeah, our builder or innovator shout outs for this week goes to Instance Form. Alright, so Instance Forms is one of those crazily innovative things I've come across in recent times. Right. So Instance Forms is a platform or is an app whereby, instead of brain racking and thinking of what should be in your form field and what should not be, right? With Instance Forms, you can automatically create and generate you know um, questions for your form field for whatever type of form you're trying to create, right? So whether you're trying to create an event form, or even if you're trying to create quizzes, let's say after this stream I want to have maybe a sort of quiz or a test, for my audience, I can make use of Instance Form even without me writing out the questions. All I just need to do is prompt. So this has made a lot of things easy, right? That makes things so much easier, right? So now let's see what Instance Forms is about. So it says no delays, no hassle, just Instance Forms. Right. So from onboardings to surveys, Instance Form helps businesses automate the creation and eliminate manual processes with ease. Right. And one beautiful thing about Instance Form is you can text with prompt. I sorry, you can prompt with text, you can prompt with voice notes, and you can use a photo snap. Right, so this is you basically uploading a photo to Instance Form, and it helps to generate uh, the form fields that are needed for your form. That's I don't know. I feel pumped up. Because now this is a great solution, and this saves from a lot of stress. I've walked around, creating forms, and I just rack my head. What do I need to ask? What do I need to know? Or what kind of questions do I need to include in my form? But with a solution like Instance Forms, right, it has just made the whole process easy and stress free. Right. And before I say a lot about this, let's see a demo on what Instance Form, or how Instance Form works. Alright, so I think this is still loading. Shouldn't take this long. I could be wrong. Okay. Alright. This is beautiful. This is beautiful, and yeah, shout out to Daniel Abemiwo. Is the master brain behind this platform, and is doing something really amazing, right? The world is not ready to get hold of this, right? So yeah, you can get started for free. And these are some of the different things you can utilize Instance Form for, right? Product feedback, events registration, employee onboarding, research. Just It's just a lot. And AI powered features that makes a difference. So seamlessly integrates for effective sharing. So there's just a lot you can you can enjoy with a platform like Instance Forms. So I'm going to add the link to Instance Forms to the comment section. All right. All right. So let me also add it here. All right, so you can see on the ticker in the bottom lower third of the screen, right? You're going to see the link to instance form, right? And no, instance form is just a lot, right? So from idea to live form in 3 steps. So it's so simple. It's so simple. You don't even need to stress your brain, go through mental stress just to create form, right? Instant form has simplified everything we need, right? So no drag and drop, no settings means just describe what you need and get ready to deploy a form, right? So you start from describing it, instance form builds it, and you deploy it in one tap. So whether you're deploying to Google Forms, you want to save it as a reusable template, or you are deploying to whichever type of form, right? So easy and also free. It's made for everyone: businesses, researchers, marketers, educators, HR professional, event planners, and so much more. And the amazing thing about this is instance form has a free plan, so you don't even need to break the bank before you can make use of something as beautiful as this, right? So with just $0, 0 naira, you can get to make use of instance form. And even the pro plan of instance form isn't something you need to break the bank for. Just 4.99 USD per month, and you get all of the functions which you need. And do you want to make use of more features, or do you require more features in your instance form plan, right? There's a contact us button here where you can use to reach out to the forms team, and they'll create a solution based on your need. All right. So yeah, you can check out instance forms today and enjoy seamless and hassle-free form creation. All right. And yeah, instance form is available on both Apple and Google Play Store. Right. So if you're an Android user or if you're an iOS user, you have instance forms ready to satisfy your need, right? And please do well to follow instance forms on their social media pages: Instagram, X, TikTok, Facebook, LinkedIn. Make sure you give instance forms a follow, and stay tuned to the amazing features you'll be shipping out in coming times, right? So yeah, thank you instance forms for building such a beautiful solution, and for the impact you're going to be making in the lives of people who need solution like this, especially for the free plan. Thank you. All right. So yeah, that's it, and I think it's a good time to bring the stream to an end. All right. Thank you all for those who joined, and even for those who will maybe go back to watch this stream if you're not able to join at this time. All right. Thank you so much. It's good to have you here, and I hope to see you next weekend again. All right. I hope to see you next weekend again, where we'll go over, or where we build new solutions and learn new things, right? So yeah, until then, uh, I'm in juice. Bye.